then perpendicular lines will have opposite reciprocals. So opposite reciprocals are like if I have A over B as a slope, so rise is A, run is B, my opposite reciprocal would be negative B over A. So we make the slope negative, and then we also will make the reciprocal, so B over A. So when we're looking at parallel perpendiculars, we're just figuring out what are the slopes of these lines, and then we can start to determine if they're parallel perpendicular, or they could be neither. So if the slopes are just different and they don't have any of those special patterns, that's going to be neither. So we will continue to look at that concept today. So yesterday, Ms. Garretts went through example 2. Today, we will take a look at example 3. So example 3 says, given two equations, determine if they are perpendicular or parallel. And in order to tell if they're perpendicular or parallel, it's going to be all about their slopes. So we got to figure out what are the slopes of these lines. And both of these are in standard form. And to determine what the slope is, we have to figure out what the slope-intercept form is. So it's the only way we can tell. So we can't just look at the number in front of the x here because it's not solved out for y. So we can't use that strategy like we kind of did yesterday when we were putting them into slope-intercept form. We could do that. But to solve an equation for slope-intercept form, there's 2 steps to it. So ultimately, we want to get y alone right here. And the first step is always going to be to get the x term moved to the other side. So we're going to add or subtract it. So if it's a positive 8x, we are going to subtract 8x. So we're going to have 16y left on the left side, and then we're going to have a negative 8x plus 16. And my preference is to always just put the x term first so that it's similar to mx plus b when I get it into slope-intercept form. Secondly, we'll divide everything by 16. So there's your second step. So the 2 steps are add or subtract your x term over. So get the x opposite of the y. If it already is, you don't have to do that step. And then divide by the y term. So we're dividing by 16. Now there's a bunch of simplifying possible that we could do, but the only thing that we're concerned about is the slope. That's going to be this number in front of the x. So you focus in on that fraction. That fraction is negative 8 over 16. Now 8 and 16, you should think about, those have common factor of 8, so this is going to simplify to negative 1/2. So all I'm worried about when I'm telling if it's parallel or perpendicular is what is the slope. So this line is going to have a slope of negative 1/2. Heading over to my second line, I've got a 6x minus 3y equals 12. So we'll get this one set up. And here I'm going to subtract my 6x over. So negative 3y is going to equal negative 6x plus 12. And then just like on the previous problem, we divide everything by the y term. But again, you're only concerned about the slopes. You're only concerned about what's happening in this spot right here. And when I do a negative 6 divided by negative 3, that's going to give me a slope of 2, or I'm going to write it as 2 over 1. So then you take a look at these 2 slopes. One is negative, one is positive. Check. That's going to be one of the things we need when we're looking for perpendiculars is one negative, one positive. And then are they reciprocals of each other? So 1/2, and then we flip it over, 2 over 1. They are reciprocals of each other, so this one is going to be perpendicular. So there's how we can determine if lines are parallel or perpendicular. From standard form, we have to solve it out for the y, which takes those 2 steps. Once we get the y solved out, now we can start to determine where that x in front of my my slope, in front of that x, that's going to be where my slope is. Heading down to part B, it says A, B, and C are collinear. D, E, and F are collinear. Compare the equations through these points. So again, we're going to look for whether or not we have parallel or perpendiculars. So what we could do here is we could just pick out 2 points and look at what the slope is. So there's an x and a y, there's an x and a y. So we could do our slope formula, which is y2 minus y1 over x2 minus x1, so we get 2.5 minus 4. So I'm doing my y's subtract. We could do 1 minus 4, and we end up with 1.5 over 3, which simplifies to 1/2. So there we have a slope of 1/2. We could also then take a look at the D, E, and F line. So D, E, and F is collinear. So I'm going to pick the two that are whole numbers, and we could find the slope of those. So we could take 2 minus, I keep doing the x's. We got to do the y's. So we could do -2 minus -3 over 4 minus 2, finding the slope between those. And we'd end up getting -1 over 2, which is, that would just be +1 over 2, which now we can see that slope of 1/2 for my line that's A, B, and C, slope of 1/2 for also my line that's through D, E, and F. So this one is going to be parallel. So anytime we see those parallel lines, we will start to see those slopes are going to be exactly the same. So the 2 points that I chose from A, B, and C gave me a slope of 1/2, and the 2 points that I chose from the D, E, and F, you can choose any two of those points. You don't have to choose the same ones I did. And then that'll give you parallel lines. So there's where we could find that those are parallel. So again, we're just reinforcing that your lines that are perpendicular are going to have opposite reciprocal slopes. Lines that are parallel are going to be exactly the same slopes. Heading down to example 4. Example 4 is going to use equations that have just one variable. So just a reminder, any y equals equation, we talked about this when we did lesson 34 just recently. Y equals -4 is a horizontal. So if I want to get something perpendicular to that, I need to go vertical. And vertical are x equals equations. So then I look at my point. I want to go through this point. So I have to have a point, I have to have an equation of x equals -5. So if I'm given a y equals equations will go horizontal across. X equals equations are going to go perpendicular. So that would mean I have to have x equals 5. So here I'm starting with a vertical. So if I want to go perpendicular to a vertical, perpendicular is going to be horizontal. And horizontal is going to be a y equals equation. So we go and find our y coordinate, y equals 3. So I'm using that coordinate right there. There's going to be my equation that's going to be perpendicular. So again, x equals equations, y equals equations, those are the equations. X equals goes vertical, y equals goes horizontal. And if you need a picture of those, you can always open up Desmos. If you click on that on our schedule, if you click on Desmos and if you just type in x equals 4 or x equals 6, whatever equation you want to type in, you will get a picture of that just to kind of help reinforce and remind you about what those vertical and horizontal lines do. So Desmos is that green icon right there. All right, lastly, use what you've learned about the properties of perpendicular lines to prove that ABC is a right triangle. So in order to figure out if it's a right triangle, we need to have a 90-degree right here. It needs to be perpendicular. So we need to see, do we have opposite reciprocal slopes? So we'll start, I'm going to highlight this in blue, even though it's kind of already blue. If I look at this line, it's going to rise 1, run 1, rise 1, run 1. So the blue line is going to have a slope of 1 over 1. Then I look at this second line where it's meeting. I'm going to look at the slope of this line right here, this red line. So m equals, here's the red line. I look at this slope, it's going to go down 1 over 1, down 1 over 1, which is a rise of -1 and a run of 1. Now we look at those. One of those is positive, one of those is negative. That's what we need for perpendiculars. And then technically they are reciprocals of each other because they're both numerator, denominator are 1s. So they are opposite reciprocal slopes, which is going to make these perpendicular. So we have perpendicular lines, which means that that angle right there is going to be a right angle because we have those opposite reciprocals.